We're still finishing the notes. Friday. All right, guys. Are there any questions on any of the assignments before we finish up the note sheet really from Friday? So we have this problem we're going to cover just so we get another refresher with the, not the fundamental theorem of algebra, but our rational zeros theorem. So we look at the rational zero one more time, and then we have one last thing to cover with this note sheet. 4.5. I have a feeling that everybody took all the extra copies, so there aren't any. I can give you this for now, and then I can run a copy of it off, and it'll be in the office at the end of the hour. That way you can have it. So when we look at this here, we'll go over the rational zero theorem again, and we're going to find that. Now the rational zeros is we're going to find the factors of the constant term and leading coefficient. Because our rational zeros theorem stated that the rational zeros for any higher degree polynomial function is going to be the factors of p, factors of the constant term, over the factors of the leading coefficient. Find it. So our constant term in this case is 12. So our factors of 12 would be 1 and 12, 2 and 6, and then 3 and 4. Now the leading coefficient is going to be the number in front of the variable with the biggest exponent, which would be, exponent would be 4, number would be 3, so our factors are going to be 1 and 3. Now to find the rational zeros, we're going to take p over q. And in front of each one, we will have plus or minus. Do it in a different color so we can plus or minus. And the way that I do this is I take the first factor of q and divide everything by it first, just so we can kind of keep track of it. So that means we're going to first off divide all the values of p by 1, which will really give us plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. Because when we divide by 1, it's really not changing anything, it's just division of 1. Any questions on this so far? And then we'll move over to the next factor of q, which is 3, and do it again. So we'll do 1 divided by 3 is 1/3. Then we'll move over to 2 divided by 3, which is 2/3. Then we have 3 divided by 3, which is 1. And we already have it. Anytime we have one that repeats or we already have listed, we're not going to rewrite it again. 4 divided by 3, we will need. And that's probably going to be the last one because 6 divided by 3 is 2. 12 divided by 3 is, so we have them all. Now let's see how many it gave us. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 unique rational zeros, because we didn't count the 1, 2, 3 repeats that we had. But how many actual zeros do we have for this function? 4. 4. There's only going to be 4 answers. But we have 18 possible answers. So only 4 of them will work. Now, if we went by the pure mathematical way to do this, well, we would start with 1 and then try -1 and go from there using synthetic division. Well, what's the other way that we can do this? We can plug it into the calculator. So we'll hit y equals. So we have 3x to the 4th minus 2x cubed. Yep. Minus 2x to the 3rd minus 37x squared. X squared plus, what is it, 42x? No, that seems too big. 24x plus 12. And once we get this typed in, we'll tell it to graph. Now we do have 4 solutions. We do have 4 places that it crosses. We have those crossing at these 3 places here. So 1, 2, 3. So we have one that's between -3 and -4. And the one between -4 and -3, it's kind of hard to tell if it's leaning one side or the other, but it is definitely close to the center. Then we have one between -1 and 0. And we can say for certain that is closer to 0 than it is to -1. Then the next one looks like it hits dead on 1. And then the one after that is between 2, 3, and 4. Now let's look at the table. Well, before we look at the table, when we're talking about the y values for this graph, when it crosses the x-axis, the value of y is going from what to what? From +2 or -2, right? Okay, so if we look at the table, well, as I'm looking at these y values from -7, -6 for the x values coming down, well, when x is -4, we have +220, yes? And when x is -3, we get -96, yes? So somewhere between those two, it crossed the x-axis, yes? Because it went from positive to negative. Okay, we keep going down. Well, between when x is -1 and x is 0, it went from negative to positive. So it crossed the x-axis somewhere between there. Well, we do have that x is equal to 1 because the y value is 0. And then it switches over from positive to, well, 0 is not positive or negative, but we do go back to a negative. And if we scroll down just a little bit, because at 0, we do expect it to change because it's crossing the x-axis, so it should expect it to be negative. And then, okay, between 3 and 4 went from negative to positive. So that's where we can know that there are solutions there. But the one I would want to use first is when x is 1. And what we're going to do is use synthetic division. 3, -2. Negative 37. 24 and 12. Bring down the 3. 1 times 3 is? 3. Negative 2 plus 3 is? 1. 1 times 1 is? 1. Negative 37 plus 1 is negative 36. 1 times negative 36 is? Negative 36. 24 plus negative 36 is negative 12. 1 times negative 12 is still negative 12. And 12 plus negative 12 is 0. Okay. Let's throw you over here. So we do know one of the solutions for this here is x. Oh, okay. X is equal to 1. Now we need 3 more, yes? Will 1, 2, 3, 4, 6, or 12 be a solution? No. Because we do have that 1 did work. Okay. That's odd. 1 did work, but it only worked once. Because we have a total of 4 solutions. We do see that it crossed 3 other places. So 1's going to only work 1 time. So the other solutions that we have can't be any of these 3 here. It's got to be one of these over here. But that did eliminate 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we're really left with 6 possible answer choices for the other 3. Now, the ones that we have left, we have 2 that are negative, one that's going to be between negative 4 and negative 3, one that's going to be between negative 1 and 0 and really close to 0, and we have one between 3 and 4. Which one of these do we want to try to find first? 1/3. So since it's close to 0 on the negative side, we would be trying not 1/3, but negative 1/3. We can bring down the 3. Negative 1/3 times 3 is negative 1. 1 plus negative 1 is 0. Negative 1/3 times 0 is negative 36 plus 0 is, well, negative 36. And the next one would be 12. And negative 12 plus 12 is 0. So 1 and negative 1/3 are 2 of our answer choices. Now we could go and try to plug the other ones in to see if they work, or we can just go on and plug the variables back in and solve from there. Let's just go on and plug the variables back in. Okay. So what we have is 3x squared minus 36 is equal to 0. Now for this here, do we have a middle term? No. Yes. Yes. So we can add 36 to both sides because these will cancel, telling us that 3x squared is equal to 36. Then we would divide both sides by 3, telling us that x squared is equal to 12. And what would we do next? Square root. X is equal to plus or minus 2 square root of 3. Because 12 is 4 times 3. Square root of 4 is 2. Square root of 3 doesn't simplify, so we get this here. Also, the yellow calculators, the TI-30XS, will simplify radicals. So they're good to have on hand. So these positive 2 square root of 3 and negative 2 square root of 3 are our answers 1 and negative 1/3. All 4 of these are the answers for this problem here. But again, the biggest thing with these here is if I can get it down to a quadratic, then I can find the rest. Any questions on this here? Now, luckily, I'm not going to be so mean as to make them where they're all complex or all irrational solutions, because then we have to actually do other techniques, especially using calculators to approximate and figure it out. Now, this brings us to the last part of this section, and that's the irrational conjugate theorem. Let f be a polynomial function with rational coefficients, and let a and b be rational numbers such that square root of b is irrational, such that if a plus the square root of b is a 0, then a minus the square root of b has to be a 0 also. Because think about it, all the ones that we've done so far, if I had a square root, we've had to have a positive and a negative of it. They always come in pairs. The same is true for our complex numbers. If I have a positive bi, I also have to have the negative bi. If we have one, we have to have the other. So, what we're going to do for this last part is finding the polynomial of least degree that has a rational coefficient and a leading coefficient of 1. And zeros of 3 and 2 plus the square root of 5. What they're talking about, polynomial of least degree, is saying that all of these zeros only appear once. Bless you. Because if we're just listing them out, we don't always have to list out the repeat. So least degree, we're talking about the smallest one. And leading coefficient of 1, that means we're not multiplying it by 2, 3, 5, because that really doesn't change the solution, it just changes everything else. But what it does tell us is that the zeros, so it's saying that x is equal to 3 and x is equal to 2 plus the square root of 5. I don't know why it's changing colors. Yep. What would the other 0 be? 2. Because if 2 plus the square root of 5 is a solution, 2 minus the square root of 5 has to be a solution as well. If we have one of the radicals, we have to have the other. Questions on this here? Now, to find the polynomial, the first thing we'll have to do is get each one of these equal to 0. We have to get them back equal to 0. Now, x equals 3 is probably going to be the easier one out of the group, because I just need to subtract 3 from both sides, which tells me that x minus 3 is equal to 0, because we just moved it back over. Now for the middle one, what can we move first? Really doesn't. 2. So we can minus 2 from both sides, which tells me x minus 2 is equal to square root of 5. Well, it's not equal to 0. So now we have to subtract the square root of 5 from both sides, which tells me that I have x minus 2 minus square root of 5 is equal to almost. We got to do the same thing with the last one. which will almost be the same as the other one, except we're going to be adding the square root of 5. So really what happened, the signs in front of each of the numbers flipped, didn't they? Okay. Any questions on this here so far? So we want the polynomial, yes? Because when we started with factoring quadratics, because we had the quadratic function, we factored it to multiple things, multiple sets of parentheses being multiplied together that equals 0. Zero product property says that I can set each one of them equal to 0. If there's more than one thing multiplied together equals 0, one of them has to be 0. Set them all equal to 0, then solved, yes? We're going backwards because we had it solved, so we set them equal to 0. Now I have three things that equal to 0. Well, guess what we're going to do? We're going to multiply them together. So we have x minus 3 times x minus 2 minus square root of 5 times x minus 2 plus square root of 5 is equal to 0. Now we talked about multiplication last week. I said the order of which we multiply any two things really doesn't matter, except there's some cases where we're going to want to prioritize multiplying two things together. This is one of those cases. Because in any of the polynomials that we have, did we have a square root as one of the coefficients, as a number in front of it? Well, no. Normally we don't have that, right? It ends up coming in as the answer. We're going to multiply those pairs together first. So these two here. Anytime I have these conjugate pairs, I'm multiplying them together first. And we'll see why here. So I'm not so much worried about the x minus 3. We can multiply it later. It'll come out front. So we're going to distribute this here. So we'll have x times x, which is x squared. Then we'll have x times negative 2, which is negative 2x. And then x times the square root of 5 is plus x square root of 5. So we distributed through that x. Any questions on this so far? Now we're going to distribute through with the negative 2. So negative 2 times x is negative 2x. Negative 2 times negative 2 is going to be plus 4. And negative 2 times square root of 5 is negative 2 square root of 5. And lastly, square root of 5. Negative square root of 5 times x is negative x square root of 5. Negative square root of 5 times negative square root of 2 is going to be plus 2 square root of 5. And lastly, negative square root of 5 times square root of 5, well, the square root and square root would cancel, leaving us with just 5, because it would be the square root of 5 squared, or the square root of 25. Well, the square root of 25 is 5. The square root squared cancels out. We just got 5. But let's look at something else here. So highlight. Well, here we have x squared of 5, yes? And over here we have negative x squared of 5. They cancel each other out. We also have negative 2 square root of 5 here and 2 square root of 5. Well, these are. So do we have anything left in here with the square root? No. That's why we do these first. Because we still have the x minus 3. Here we've got x squared, because it's by itself. Negative 2x would give us negative 4x. 4 minus 5 is? So after we finish that, we end up with a trinomial. We end up with 3 terms. Y'all ready for the last step? Distribute one last time. x times x squared is x cubed. X times negative 4x is negative 4x squared. And x times negative 1 is negative x. We'll do the same thing with negative 3. Negative 3 times x squared is negative 3x squared. Negative 3 times negative 4x is going to be plus 12x. And negative 3 times negative 1 is plus 3 equals 0. I'll scroll back up. And last but not least, we do need to combine like terms. Well then. I probably come on. X cubed. Negative 4x squared minus 3x squared would be negative 7x squared. Negative x plus 12x is plus 11x plus 3 is equal to. So this here is the polynomial of least degree with a leading coefficient of 1. And that's it. Yep. Any questions on any of this here? So, do y'all want to see another example of one of these here? Okay. But that is it for 4.5. So this is on page 203. So what we're covering next in the last section is 4.6. And that's going to take 3 days. But if you notice, the majority of the days isn't so much we're covering a lot of new stuff, it's just the example problems take a while. Now, when y'all start actually doing them on your own, they will go a lot faster than what we've been doing in class. Because whenever I teach them and we go through them, there is a lot of pausing and a lot more time than it actually takes.